Hello, welcome to part 5, I think, of the follow along wall slammer escape project, where we're going to fix up some of our code architecture. So the original assignment was, following on the video, was before we covered object inheritance and before we covered event systems. And this video is going to be using both of those two concepts to clean up some of our code. And I'm not sure when I'm going to assign this video to be watched, if ever. Maybe it'll just be here for a reference or something. But we're going to go over how we would make those changes, and I'm going to record the process of doing that in this real, actual project that you're familiar with. Nice. So first, let's go over object inheritance. Our trouble was in the interactables. So in our scene, where's our scene? Hello. There you go. In our scene, we had these little pickup items, and anything that you could hover on top of would be something that the player interacted with. So these items that give you an extra health, which I realize now should probably be like green, like the player. The goal that you end and you win if you go over it, and a future puzzle. I had two mechanics I thought of that I haven't implemented. One is boxes that can be smashed, but only from certain directions. So you got to go through them this way to free up the ability to go through them that way. And then the second would be switches, boxes that can get turned on and off. That's not here. And then for another one for smashing through things is switches. You land on the switch. That's the interactable part. And then it talks to another box somewhere else. Yeah. Or maybe you hit a box and it could turn itself on and off, or off, and that's weird. Anyway, lots of ideas for mechanics on how you can manipulate and change a level. Anything that changes the grid system could be something we could play with in the design world. But all that stuff would be something that you interact with when you overlap it in interactable. So our system, we have separated interactable to its own script, and we separated the unique behavior, like picking up an object or the goal, to its own script. And so we have the interactable object grabbing the goal pickup and basically calling the interact function of those other scripts. And we're going to change this. We're going to fix this by making it simpler, where we don't have this overhead, we don't have this memory use. We just have the objects that are somehow both their own unique thing and a type of interactable. And we do that with object inheritance. So on our interactable script, we're going to leave it a mono behavior, and we're going to get rid of goal and private. We're going to get rid of this await call, and we're going to basically get rid of all of our logic. Oh no, it's all broken. What do we do? What we're going to do is we're going to make this function that still gets used, it still gets called. We're going to make it virtual. And that's, we're going to make it virtual. And making it virtual is a label. It's kind of an odd word. To me, that's not what the word virtual means. To me, virtualization and into computer systems and things like that. But to computers, it's just a keyword. We don't care, why they picked it. It means that this object can be replaced by this method can be replaced by a version of that function written in a child object, a descending object. Gosh, I didn't say that well, did I? Oh well, moving on. So we go to the goal. And now in the goal, nothing is ever going to call this player at goal function. It's never going to get called. Instead, we're going to make this object not a mono behavior. We're going to make it an interactable. And it's going to extend interactable. So our interactable extends mono behavior, and our goal extends interactable. So it's still a mono behavior. And it is going to have, instead of player at goal, we're going to have that interact function. What do we call it? Interact. And what we need, we're going to get an error here because we need to override the object in the parent class. Remember, C# doesn't make any assumptions for us. I both need to tell this function that it's going to override a function in the parent class, and I need the parent class to say, yes, it's okay for you to do that. Both of those things need to happen. Because C# is very specific and explicit about what is happening. And I can look at this script and I can know that it's doing an override, and I can look at this script and I know that it's being overridden and that it's allowed to. Let's go to the pickup and just do the same thing. Our mono behavior is going to be an interactable. And we're going to change, let's do it with a little bit of autocomplete. If I just type override, it'll give me all the different functions I can override. And we're going to override interact. And that generated it. There we go. I don't need to call the base.interact function because this doesn't implement any logic here. In fact, this is an abstract class, but listen, I'm introducing one concept and one keyword at a time. We'll get to abstract classes pretty soon. It's basically abstract. We can just whatever. It's gonna be the error because it doesn't. Okay, it doesn't implement its own functionality. And it can't be instantiated itself as a component. Only the children objects are the real ones. And that's kind of how we're using this, so it should be abstract, but we're going one step at a time. Okay. So it is no longer grabbing the interactable component and then calling the other classes. Instead, it is grabbing when the player overlaps with the goal, it says get component interactable. It returns the goal as an interactable. It knows because it's an interactable that it has this interact function, and it calls it on this goal object of data. And it's gonna do the thing. So let's go back to Unity and fix up our code. Here on the pickup script, this interactable, if I did make that abstract, this would give me a nice error and I would know how to fix it and remove it. But now I know to remove it. We'll apply that to the prefab. And it's just a pickup. And we go to the level goal. And we can get rid of this removed object because this goal is the interactable. It is a mono behavior and it is an interactable. So the player, took me a long time to click that button. The player gained a life. It hit the target, it hit the end, we won. Everything just kind of worked. Everything just worked. Even though there's no interactable component anymore. So let's debug that and let's just take a closer look at how it's happening. Where's my player movement? Script where I check for my interactables. We're going to put a debug log there. We're going to put a debug log statement here. And run our game. Our game froze because it was frozen. We can see we began in a move script, and then that called the move once recursive function. We moved to this is the next position. And then that called the move once recursive function, and that's the next position. And that called the move once recursive function with that next position. And blah, 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 blah. That's the fun for a recursive function. Next, this call came through, and it called the check for interactable function, which was happening before, but just, this is how we got to this point. And we got to this, so that's this function called now, being called from the move once recursive function, and the code reached this point here, and now let's step through. So this interactable variable is null. It hasn't been created yet. We can go to the next line. It hasn't executed this line of code yet. We can click through it, and now we can see that this interactable object that we're getting from the get component call, it's equal to pickup. It's equal to the pickup object. Is that coming through in the video? Yeah, pickup. So when it looked for the interactable component, it found pickup because it is an interactable component. So we can step through and we can see that it's not null, and we can call the interactable.interact function. If I were to look at all the functions available to me on this interact function, I would only see interact and mono behavior functions because it doesn't know specifically about the pickup. It doesn't know about, well, there's nothing else here really, but it doesn't know about this. Well, I wouldn't know about that because it's private. If there was another public function on the pickup script, we wouldn't be able to call it because we only know of it as far as it is a version of interactable. If I'm wearing we have a shirt, right? Is that shirt a t-shirt? Is that shirt how does it have breast pockets? Does it button up the center? Does it zip up? There are lots of different ways the shirt can work and we can implement the idea of shirt. So if I say, hey, I'm gonna grab a shirt, and you say, yeah, put something in your front left pocket, I'm gonna go, well, I may or may not have that. What do you like? Shirt doesn't have that. That's not, we need a shirt with pockets. A pickup. I'm explaining things worse and worse as I go, aren't I? Okay, so we interact with it, and then that's going to call the interact function, and our code continues. And let me stop debugging. And now we're over here. Yay. Pretty cool. Pretty cool. So now it's really easy for me to add more features. I could add that crate that gets destroyed when you smash into it. And it can maybe check what direction the player is coming from. Gosh, I would need to, I would need to have that in, I need to pass in like some player information, your movement direction and stuff through that function. Maybe optionally. We could do that. But that's a different problem. Let's fix something else. Let's fix our game manager. We have two problems with the game manager. Where am I at? 10 minutes? That's exactly right. Now we got 10 minutes to do this part. At least in my goal of how long I want to go. Let's fix the game manager. We have two problems with the game manager. The first is how we are accessing the game manager as a singleton. We know there's only one of it, so there should be an easier way to access that single thing. We're going to fix that second, and maybe not in this video, because singleton patterns are kind of annoying, and I don't want you copying them and using them forever. But another thing we need to fix is the game state. There are a number of functions that are listening to the game state. The player effects has a cached as a reference to it. The UI manager has a reference to it. All sorts of functions are using getting this game state function. And they are checking to see when it's changing or not. Our UI manager, our UI lives indicator, right? It's checking every single frame. That's for lives. Our UI manager is checking every single frame to see if the game state has changed, and it only wants to run this code when the game state changes. Same for the player movement. Same for all the other scripts that are like dealing with paying attention to it. Most of them only actually care about when the game state changes. So we're going to make an event called on game state change or something like that. And we're going to have all of these listeners subscribe to it. So we'll go to our game manager, and we're going to use the action C# feature to do this. So we're going to make a public. Let's make it static. We have the singleton pattern. We can get away with making it static. Action on game state change. And let's use the system.action system class to get system.action. And let's actually pass the game state that's changed, the new game state, through when we change the game state. And then let's write a little function to wrap up. Let's make it private. Change game state. Game state, new game state, and this will take the current game state and set it equal to the new game state. And then wherever we want to change the game state, we'll change it using this function instead of changing it directly. So in start, we'll do change game state to playing. In in lose, we'll do change game state to game state dot lost. In one, change game state to game state dot one. So now I only need to write this event code once. I kind of want to move this down. Move it down to be next to my other game state function. And what we're going to do is we're going to take that action, question mark dot invoke new game state. Question mark? we've covered action, the syntax of actions, but I'll just review it here. Our action, if it is not null, call this function. This is a shorthand for writing this one line code writes these lines of code. Is this. It's just a shorthand way of doing it. Nice. So, and we always use it for actions because we need to make sure they're not null. So, great. This all should work. We didn't really change any of the logic. So let's go into the, let's use the UI manager where we had even had a bug from not having this. Let's get rid of this update function. Goodbye. Let's go to start. Goodbye. And let's, I don't know why I'm very tired. And we'll say update display state, and we'll have it receive a new state. And we'll just pass this new state in. Great. Now we actually don't need our game manager reference. We're not going to need it. Ooh, because the action is static, we only need a reference to this action. We don't need the other stuff. So void on enable and on disable, we will take our game manager in caps because we're referencing a static property. We're going to referencing the on game change state, and we're going to add a listener, and that listener is going to be update display state. And the action properties matches the properties that this takes. It is one of type game state. So we can do that. And then we just have to make sure we unsubscribe because otherwise everything will break. On enable will happen before start. So we'll be listening to it when on start, this playing event gets broadcasted and our manager will update. It should update once and set everything when we begin playing. So we can remove this currently displayed game state as well. Pretty clean. Pretty clean. I have combined these two patterns before. I often have instead of using, this is kind of a dirty pattern. Maybe it's not a great pattern, but I like it. I'll make a parent base class for like an agent in a grid game or something, like somebody can move that often has a bunch of events. I'll subscribe to all those events in a parent class and then call virtual functions and do all that listener code once in the virtual class. And then the children will just may or may not override them. It's fine. It works all right. It feels clean to write. It feels really easy to understand. There's other ways you can do things. So let's make sure our UI isn't broken. Win. Excellent. It still happens. Nice. Our last thing to fix, how am I on time? Ooh, we're under time, 2 minutes under time, is to give ourselves a static reference to the game manager. And then maybe we can find other places that care about that change. Who else uses get game state? Player effects. Ooh, yeah, we can do the listener here. Let's do it here. Enable game manager dot on game state change plus equals, make that for me. Private void on disable game manager dot on game state change minus equals, don't create it, game state change. And then this code will go in here. And this game state will be the new state. And new state, we'll replace these parts. use a switch statement, but we're not gonna. Only so much new syntax at a time, right? Okay. Game manager. All right, who else uses get game state? Play movement.move. Yeah, because you're not moving only what, you're moving on your own time. So we can just get the game state. And we need a direct reference to the game manager in this class anyway. So we don't need to refactor that one. Okay. Now we're going to participate in the Singleton pattern. And we're going to make a variable called instance. We're going to make two variables. I kind of hate singletons. Okay. Write a little fancy get custom getter. It's just shorthand for writing public getter, private setter. There's other ways to write that code. We kind of did the same thing earlier with public, a public getter for get game state, and it was otherwise private. But there's other, now it's as a variable. Anyone can read this variable, but only this object can change it because it's private. Okay. In awake, we're gonna check if instance is not null, and if it's not null, we're gonna destroy ourselves. And if it is null, we're gonna set ourselves to be equal to it. We can do it lazily at the first time somebody tries to grab instance, but I mean, having mono behaviors where Unity controls the creation and destruction of an object and a singleton pattern, which should have nobody allowed to create and destroy it. It should just exist and be itself. There's like no perfect way to implement singletons in Unity as mono behaviors. I like using scriptable objects for singletons, which is to many developers' eyes an insane thing to do. But it allows me to, it doesn't ensure that there's only one, but I do that myself from like the file menu. It lets me use multiple ones in testing. We are doing exactly that pattern for the level manager in this project. This could be a singleton and we could do it, but not really, because I want these start calls. So then I'd need a thing in the scene calling it, So it wouldn't really fit well there. Okay, so you have our game manager. I'm gonna put 6 in the scene, which is definitely broken, and we've broken our rule. We have more than one game manager. Oh no, we're all gonna break? What are we gonna do? Well, they all destroyed themselves except for apparently the number 5, and everything should have a reference to number 5. The player's turn were taken. We lost the lives. It all worked. So it enforced that there can only be one game manager in the scene. And more importantly, it has given ourselves a way we can access this property. So let's go to our player script. And let's get rid of this reference to this find object of type code. That's what we're trying to get rid of, the slow function call, which had the same assumption. It's still required that there be only one game manager. Well, A, we've enforced that that's true now. But B, we can take advantage of it to allow an easy point of access, this private, this public instance class, which is static, so anybody can access it with this capital G. And then it will refer to the specific instance version of the non-static version would be instance, and then we can run code on that. And that's the singleton pattern. So cool. We go to the game manager and let's see who else is using get game state. Player movement is, who else is using lose, right? Turn taken is, who's using turn taken, player is, who's using win, our goal script. So we can do that. We can get rid of that. We can make that like that. Clean that up. Anyone else using the game manager? There's a pickup. There we go. See, so that's the E. That's why we like singletons. That's why we like singletons. Hey, I need to get an extra life. Okay, well, I just type the code, the one line to get an extra life, and I don't need to store a variable, and I don't need to find it in awake or do any of that stuff. I just do it, and it works. Yeah, singletons very. Everyone's got an opinion about them, and my opinion is that I don't like them very much, but I use them all the time because they just kind of work, especially for the types of prototyping projects I make and the scale that I make on them. Lives indicator uses it, right? Game manager, don't need awake. Nice. Right. If I can, how do I find file? Find in files. Find object of type. That's a text mesh pro script. Whoops, didn't want to open it. Okay. So it looks like we're good. Looks like we got them all. Let's see if our game still works. So the game manager, it has some properties here that are level specific, like how many lives you might have on a per level basis. Maybe only 3, maybe more than 3. So I can't do the another trick where I actually don't have none of them in the scene, and then we only make one in our main menu or loading scene, and we have it there, and we have it not destroy on load. But this entire project is built in a way that we avoid using multiple scenes. We've gone kind of out of our way to avoid don't destroy on load calls and things like that. As an excuse to explore some architectural challenges, and B, I don't like it. Multiple scenes are annoying, and we don't need to learn them. So, there's 1,000 ways to break an egg. That's the saying, right? All right, what do we got on time? 27 minutes? Coming in 3 minutes under. So, to recapitulate, we changed our game manager to a singleton instance. We changed our interactables to a child instance. And that's really, whatever your opinion on singletons is, and if they add mess or remove mess, doing this single degree of inheritance, probably should make that abstract. It's virtual by implication. Okay. Am I forgetting how abstract functions work? So now we can't accidentally go add interactable, right? We can add pickup, we can add goal, but interactable isn't a thing we can add to a component, right? So that's my, we already knew that we would never use that script. It's just this parent class. Abstract is a way of us telling C#, hey, if anyone tries to just make one of these and not make one of its children, but just this on its own, they're doing it wrong. So that's what abstract allows us to do. It allows us to be very clear about the purpose of the script, which allows errors to happen, and that prevents errors, right? Error messages allow us to fix the problems before everything's broken. Okay. That's not an appropriate definition of abstracts, but if you've already kind of learned it, or we've gone over it somewhere else, or before you go learn it properly, doesn't hurt to see it. Unless you're just confused, and then I added something on top of confusion, and now you're just confused and annoyed. Hey, welcome to programming. Okay, bye.